Hi, and welcome to question 2 of the Leaving Cert Ordinary Level Paper 1 from 2021. As always, if you want to copy these notes, just send me an email at shanetroy@gmail.com. If you like these videos, just hit subscribe to get access to more playlists. So question 2 here is a complex number question. We're given two complex numbers, and we're told here that I squared is equal to minus 1. Now, this is a kind of constant thing within complex numbers. That's the same thing as saying, which is the more fundamental thing, that I is equal to the square root of minus 1. So remember that I is a number, like all numbers are complex, but they can be broken down to real, natural integers. And that ultimately, at the end of it, all numbers can be described in a complex form. Now, most numbers that we're familiar with don't have an imaginary part. So we like the word number 4 is technically 4 plus 0i, but 0i is 0, so you don't bother writing it. Now, I won't go down too much into the detail of that, but part A here is just simply saying plot and label Z1, Z2, and Z1 plus Z2. Now, we're not given Z1 plus Z2, but we are given Z1 and Z2. So let's go ahead and do it. Z1 is minus 3 plus 4i, and we plot that on what's called an Aragon diagram, where the equivalent to the y-axis is the imaginary axis, the equivalent to the x-axis is the real axis. Now, on that, they already have divisions. I'm looking for minus 3 on the real axis. That's somewhere along this line here. Where that crisscrosses with 4i is that point there. Okay, so that's the point Z1. Now Z2, okay, we're given that as well. It's 4 on the real axis, so somewhere along this line here, where that crisscrosses with plus 3i, and that's Z2. Now Z1 plus Z2, we just have to add these together. Now I'm going to put them in just as they are. Okay. Now, when you're doing anything, you're always adding like terms. So in this case, I can combine them, minus 3 plus 4, and then 4i plus 3i. Okay. If you want to combine them together, the real part, minus 3 plus 4 is the same thing as plus 1. 4i plus 3i is the same thing as 7i. That's it. That's Z1 plus Z2. So I'm looking to plot the number 1 plus 7i. So I find 1 on the real axis, okay, and then 7i up here on the imaginary axis, and that is Z1 plus Z2. That's important to label them because you were asked to plot and label. Okay, so there's marks going for that. Now, speaking of marks, there's 10 marks for this. Nice, if it's a fairly handy question in terms of complex numbers. Now, part B, I guess is the answer there, and the nicer way of doing it. Now, B is asking you to, it says another complex number, Z3, you can find it by dividing Z1 by Z2. Now, I don't know what Z3 is yet, but I do know what Z1 is. I put them over here, just screen grab them in. Z1 is minus 3 plus 4i. And at the bottom of that complex fraction is Z2, which is 4 plus 3i. Now, to divide complex numbers, you multiply, okay, top and bottom by what's called the conjugate of the bottom. It takes longer to write than I thought it would. Okay, now, what's the conjugate? In essence, on an Aragon diagram, if you had a complex number, let's just call that one there, its conjugate would be its reflection in the real axis, so it'll be down here. So the real part isn't changing, but the imaginary part is. And if this was positive up here, it's going to be negative down here. Okay, so with, let's say 4 plus 3i. With 4 plus 3i, the conjugate of that is 4 minus 3i. Now, sometimes if I call that complex number z, they might put z bar to indicate that's a conjugate. So in essence, I'm multiplying the top by 4 minus 3i, and I'm multiplying the bottom by 4 minus 3i. Now, I'm going to use the notes here because this just takes an awful long time to write it out. So I've expressed where I left off there. Okay, it's the top part multiplied by the 4 minus 3i, the bottom part multiplied by 4 minus 3i. And I've done this as one big uber calculation. And in essence, what I've done is I've written here, the second bracket, I've written it out twice. Then the first term of this first bracket I've written here. The second term of this first bracket I've written here. What I'm trying to do is make sure that everything is multiplied by everything else. Now, if I track that along, okay, minus 3 by 4 gives me minus 12. Minus 3 by minus 3i, minus by minus is plus, 3i by 3 by 3i is 9i. Now on the rest of it, 4i by 4 is 16i, and then 4i by minus 3i, plus by minus is minus, 4 by 3 is 12, I by I is I squared. Now we were told earlier that I squared is equal to minus 1, and that's going to have a bearing. Now on the bottom part here, I'm doing basically the exact same thing. Okay, if I can bring it back. So I'm just trying to erase all the ink on the slide, and I should be there. Apologies. Okay. Now on the bottom, okay, I'm multiplying 4 plus 3i by 4 minus 3i. And just as an alternative way of doing this, this is not the way I necessarily recommend, because whenever I do something like this, I'm more prone to error. But it's faster. I want to make sure that everything in the first bracket multiplies by everything in the second bracket. So you can just track it along. 4 by 4 is 16. Now 4 by minus 3i plus by minus is minus, 4 by 3i is 12i. Now here, 3i by 4i plus by plus is plus, 3i by 4i, 4 is 12i plus 12i. And then last thing, 3i by minus 3i plus by minus is minus, 3 by 3 is 9, I by I is I squared. And that's it. So it's the same answer as what I got over here. And I still have the I squared thing happening. Now, at this point, you're going to simplify it, okay, by adding like terms. So I've done for the top part of it, if you just track it down there, 9i plus 16i is 25i. Okay, I haven't affected 12. Nothing's happened to that. The i's have combined, like terms have added. And here, I've swapped, instead of I squared, I've put minus 1 in brackets, because I squared and minus 1 are the same thing. Now, what's going to happen here is, okay, minus 12 plus 25i, this minus 12 by minus 1 is going to become plus 12. That's what's going to happen. Now, minus 12 plus 12 is going to cancel. And that's why it's gone away on the next line. I'm left with the 25i. Now, the other side, the bottom part of this whole fraction, okay, complex fraction, we're left with the 16 minus 12i plus 12i minus 9i squared. Well, straight off, minus 12i plus 12i cancel. That's 0. Instead, the I squared, I put minus 1. Okay, just like before, I squared is minus 1. That's created a little arithmetic sum. 16 take 9 times negative 1 is the same thing as 16 plus 9, which is where I get the 25 here. Now, 25i divided by 25 is the same thing as 25x over 25. It's x. Okay, in this case, it's I. Now, if I left my answer there as I would lose marks, because the question says, leave your answer in the form a plus bi. Now, it also says a and b can be positive whole numbers, positive or negative whole numbers. Basically, it's a number. Now, this is in the form of bi, not a plus bi. So you have to add into, acknowledge that the a value is 0. So the answer is actually 0 plus I. You lose a mark for not putting in the right form. It's tricky because the question, you might just, I could easily fall down that if I wasn't thinking and have my knowledge of how the exam marking scheme generally works. But at the end of the day, that's it, 10C, okay, 10 marks. And it's worth pointing out that this is a standard method, okay? If you're doing it, if you can do it, okay, it's going to be fairly handy. It's just a matter of remembering how to do it.